Welcome to the Mutation Surveyor Custom Report Options webinar. My name is Phuc Nguyen, and I will be the presenter for this webinar. Mutation Surveyor has very flexible reporting capabilities in the custom report. First off, the report is interactive, giving you the ability to click on any variation in the report, and you will be taken to the mutation position in the main analysis window. The custom report has a color coding scheme that correlates with the variant tags of each mutation. This color coding scheme is entirely customizable. You also have the option to change the format of the report table that includes creating your own personal header and different options for grouping samples. The nomenclature for each mutation can be changed to different formats, and for each mutation, you can display region of interest information along with other quality metric for individual nucleotides and entire traces. And finally, you can filter out variations that you do not want to include in your final report. In other words, the entire report can be customized by you. In the Reviewing and Editing Data webinar, I briefly talk about adding custom variant tag to a mutation. This tag can also be used in conjunction with the color coding scheme in the custom report. Any called mutation can be easily edited by right-clicking on the desired variation and then selecting the Edit option. This will bring up an Edit Substitution dialog box. Located at the bottom, the Tag drop-down menu has a list of specific tag that you can designate to the selected mutation. In addition, you can also add comments to the mutation. The mutation tag designated to a variation will also be added to the GenBank file and stored as the edited GenBank file. As mentioned before, the custom report has option to color code specific tag that was added to each variance. You can access the custom report through the Report tab on the main menu toolbar and then selecting the Color tab. In this example, I assigned yellow to the pathogenic tag and green to the benign tag. Press OK and the report will automatically populate. As you can observe here, the pathogenic variants are color-coded yellow and the benign variants are colored green. In addition to the color coding scheme, the tag that was assigned by you also appears in the final report. The final report can be printed or exported as a text, Excel, or XML file. In addition to the color coding options, there are many other available settings that can alter the display of the final report. In the Format tab of the custom report, you can choose what goes into the header of the report or create your own personal header. The header can then be saved and used again for future reports. Under the table format, you can choose from displaying one trace per row to one mutation per row. In addition, there are also options to generate a consensus sequence based on specific selection. Under the grouping options, you can choose how the samples are grouped. They can be grouped by their forward and reverse pairs, by trace characters, by contig, by quality, by sample ID, and many other options in the drop-down menu. I will select to group my samples by sample ID from characters 6 to 13, then forward and reverse pair. And finally, in the group summary, you can choose to show allele information or mutation summary for each group relative to the grouping scheme chosen above. In this example, I have chosen to group my samples first by patient ID from characters 6 to 13. As you can see, the report is divided into sections, each containing all the replicate sample for a single patient ID. Then, they are grouped into their respective forward and reverse traces. In order to better observe the differences, I suggest you try a different combination of grouping method to see which way is preferable for you. Take into consideration that the first order has priority, then the second order, and then so on. In the Filter tab of the reporting options, you can choose to display all traces or just selected traces. If you are doing low-frequency variant detection, you can select to only display two directional traces with mosaic mutation and filter out all the other traces. The nucleotide quality is used to mitigate the calling of false positives when the data quality is poor based on Phred score and intensity threshold. Phred scores are discussed in the Reviewing and Editing Data webinar. The mutation call setting filters out unwanted mutation calls. For example, if you only want to see indel, you would deselect other types of mutation and only leave the indel selection checked. If you want to display possible somatic mutation, the possible mosaic option should be checked. This option only works in conjunction with the Check 2D Small Peak option in the process settings. For more information, please refer to the Low Frequency Variant Detection webinar. These filtering options can also work in conjunction with specific ROI and CDS defined by you. For more information about creating ROIs, please refer to the Creating ROI webinar. This is an example of a report that has been filtered to specifically only show low-frequency variants. As you can see here, the yellow color code for somatic mutation will be accompanied by text annotation in each variant if you select it to display comments under the Mutation tab to allow for easy identification. For more information regarding somatic mutations, please refer to the Low-Frequency Variant Detection webinar. In conjunction with the Filter tab, the Display tab controls what information are displayed. You can choose to show all information or select specific option to display. The General Information offers a normal display option such as Grouping ID, reference name, direction, gene name, and other options as you can see here. The comparison region is automatically defined by Mutation Surveyor when the analysis starts and is explained in the introductory webinar. But in a custom report, you can select to show the start, end, and size of the comparison region. The Region of Interest option gives you the flexibility to add ROI information to the final report, including a column informing you if the sequence has adequate quality for the entire region of interest. You can define an ROI in the GenBank or SEQ file and then choose to display the information by choosing the different options shown here. For more information, please refer to the Creating ROI webinar. The quality information options for traces and nucleotides are all located in this section. We will discuss this section more in detail next. The first section we will focus on is the trace quality information. You can choose to display score for entire traces, ROI, and comparison region. After selecting the region that you want, you can select the type of score you want to display, Phred score or signal-to-noise ratio. The Phred score in this case is an average of all the nucleotide in the trace. The signal-to-noise ratio is similar to lane score in the main analysis window, but it is calculated after alignment. These scores will be flagged if it is below the quality threshold. The second section contains options to display nucleotide quality information. The nucleotide quality information, however, can only display scores for each nucleotide in either comparison region or region of interest. For region of interest, there are options to display nucleotides that are below the set threshold, as well as position and score information for the failed nucleotides. As with the trace quality information, you can also have the option to select which type of score to display, Phred score, signal-to-noise ratio, and NM score. The NM score is developed by Softgenetics as an indication of the contribution of the normal allele compared to the contribution of the mutant allele by comparing the allele intensity and shape between a reference and sample trace at a specific position. The score range for a mutation are as follows. 0 indicate a homozygous substitution, 100 indicate no variation, 0.4 to 2 indicate heterozygous substitution, and 2 to 5 indicate possible low-frequency variants such as somatic mutation. Any mutation cause with a score over 5 might be a false positive and is an indication for you to review the variation. Keep in mind that these scores are merely approximation and may require manual review to confirm the variation. The NM score and Phred score works in conjunction with some of the settings in the Mutation tab, which I will discuss next. The Mutation tab will give you options to filter out certain parameters of a mutation and show normal allele information. The Show Mutation Call information display the usual parameter when a variant is detected. These parameters are the same as the parameters in the mutation table in the main analysis window. To the right of these options are filtering thresholds for certain parameters that can be set by you to filter out mutation calls. A word of caution, as these thresholds can filter out useful information if the thresholds are set too high. The Show Non-Mutation Call information has option to display normal allele information along with the mutation information. There are two important options that I want to talk about. They are the Show Negative SNP and Negative Mutation. The negative SNP will show a position where a wild type was detected in place of a reported variation in the GenBank or SEQ file. Negative mutation will show position in a group where variation was detected in some samples but not others. I will select to show negative SNP and negative mutations. The General Information has option to display specific information relative to a given nucleotide. This includes reported variance annotation including SNPs, nucleotide intensity, Phred score, and NM score. You will need to select Phred score and NM score if you have chosen to display these scores as quality metric in the Display tab. The Genotype option will tell the software that you are doing analysis based on a diploid organism and will display 2 allele at the nucleotide information. And finally, the Display information specify how the mutation call information will be distributed in table cells for display. This is an example of a custom report that is showing the Fred score, NM score, negative SNPs, and negative mutations. An M score of 0 means that the variation is most likely a homozygous substitution. The purple background indicates reported variants, while pink background indicates novel substitution that affect the amino acid sequence. The negative SNP and negative mutations include text annotation to let you know that it is either a negative SNP or negative mutation. If the reported variation is annotated correctly in a GenBank file, you can right-click a negative SNP or reported variants, and a link to dbSNP will be available. In the Nomenclature tab, there are a few available formats to display each mutation call. The first two options are known nomenclature, such as genomic and HGVS, that already has a defined standard. However, the custom option will give you the flexibility to customize the nomenclature to your needs. You can even combine some custom settings with the predefined one. For example, I can change the amino acid lettering to show 3 letters instead of the usual 1, and then switch it back to genomic. The genomic nomenclature will now display 3 letters for amino acid instead of 1. You can combine different methods to best suit your needs. The picture on the right shows the custom report change with the predefined genomic nomenclature. As you can see here in the highlighted box, the 3-letter custom change is specifying a tryptophan 128 to serine change, whereas the picture on the left is just a regular genomic nomenclature with 1-letter amino acid change specifying W128 as change. From here, you can double-click on any variation, and Mutation Surveyor will automatically take you to the mutation position in the main analysis window. Let us examine the variant at position 107, 844,000. This is the view that you would see in the main analysis window if you double-clicked on the mutation. If you click on the main analysis window for review, you will lose the report table. Simply hold down the Control key and hit the T button on your keyboard to bring the mutation table back up. The Others tab has a couple of options for saving certain settings. These options will allow you to save the process setting that was used for the analysis as well as an XML report. You can also hide selected rows or columns by selecting this option. After you are done customizing the report, all the settings can be saved as an IAI file and can be loaded into future custom reports if needed. By selecting the hide selected rows and columns, you can choose what information are displayed. Simply right-click anywhere in the report and select to either hide selected rows or hide selected columns. You can hide any rows, but the hide selected columns only work for the variation columns. The yellow background indication with text appears to let you know that you have the option to hide selected rows and columns selected. Having this option selected gives you full control over what variants and sample are displayed in the final report. The custom report table in Mutation Surveyor is interactive. This means that you can click on any mutation and the software will take you to the specific mutation in the main analysis window. You can specify color codes for specific variant tags and change formatting option for the entire report table that includes header information and a grouping of samples. In addition, it also gives you the ability to control which mutation, quality metric, and how each mutation should be displayed according to certain nomenclature standards. Mutation can be filtered to only show specific variations. And finally, the settings for the report can be saved and reproduced quickly for certain projects if needed. Other type of reports are discussed in the introductory webinar and in Chapter 4, 5, and 6 of the Mutation Surveyor Manual. This concludes Softgenetics reporting options with Mutation Surveyor webinar. If you would like more information or want to try a free 30-day trial, please visit www.softgenetics.com or send an email to info@softgenetics.com. You may also request for online training if you are interested in learning more about the software and its capabilities. Thank you for joining me in this webinar.